Hello everyone, today we're continuing on learning Rust with rustlings. And last time I think we did 30 or something exercises, and now we're gonna do structs. Alright. Add the fields that the test regular structs expects. Types should the fields have? What are the minimum and maximum values for each RGB colors? And the fields that the test double structs expects. Instantiate a regular struct. Instantiate a double struct. Okay. This is how we define a struct. What's our tuple structs? Similar to tuples. Okay. I see. So we can have, yes, structs that are tuples and they don't have named fields. Okay. So for our regular struct needs, it seems, 3 fields: red, green, and blue. And I'm gonna give it just that. And it also says that we need to think what kind of values can RGB colors have. And it's obviously from 0 to 255. And that is assigned 8-bit integer. Okay. So we have red, green, and blue. And we need to create an instance of that struct. And we create a struct like that. Create an instance of the struct. Okay. So we do let green color regular struct, and we just write down the fields. So it's red, which is 0, then we have green, which is 255, and at last we have blue, which is also 0. And also need to put a semicolon. And then we also need to create a struct, which is just kind of tuple struct, right? So we put a semicolon at the end. I'm gonna have 3 fields. All of them gonna be assigned integer of 1 byte. And need to create an instance of that struct. And we can just use regular braces, I guess. but we still have a compilation error. Okay, so we need to create a unit struct. But what's our unit structs? Structs without fields. Okay, so maybe you wanted to group some traits, but the trait, the type that you're gonna use those traits doesn't necessarily have any data inside of it. And we create it like this. Okay. What you're gonna do now? Create your own order using the update syntax and the template above. So I think we need to use this function, right? Create your own order. Does create an order already. Well, I think what it wants us to do is to just copy what the template function does. So we create new order. And just like set up the fields. So what it does is basically when we create our own order, all the fields do match the order template. Just not the count, and the name also is different. So we can do something like, I don't know, like if this is the right decision, you can clone it. So we don't have a clone trait. Okay. Well, but we can just create another one. And just change some fields, right? And we need to make it mutable. We want string. And you also need to change count. I also want to check out the solution because I don't really think that I did what they wanted me to do. But maybe I was correct. Ooh. So it wants us to use this struct update syntax. But do we actually get told how to use it? Create using the update syntax. Okay. Alright, so we did it incorrectly. We need to create in use struct. By using the already existing one. And now it should be good. No. Need to put okay, and semicolon there. All right. Structs contain data, but can also have logic. In this exercise, we have defined a package struct, and we want to test some logic attached to it. So basically, it shows us how to like create traits for structs. This isn't how you should handle errors in Rust, but we will learn about error handling later. Okay. Add the correct return type. Read the tests and see what this method does basically. Add the correct return type. Calculate the package phase. Okay. So we have like tests, a bunch of tests. 3 of them have errors. And basically international, I think it means that when the sender country isn't the same as the recipient country, right? So first of all, it returns Boolean. And it's gonna be international if sender country isn't the same as its recipient country. This should be good. But we also need to calculate fees. Now we do that. So it takes cents per gram. And it's 32 bits in signed integer. I think we should just multiply it by the weights in grams, and the return type should be 32 bits unsigned integer. And we don't need a return, but it's trust. I think this should be good. Okay. So now we're done with the structs. And we do enums. Okay. Define a few types of a message as used below. This is how we define enum. I mean, I'm not gonna copy it, I'm gonna write it up, okay? it's change color. I forgot the E. Okay, it's pretty easy. Find the different variants used below. So I think what it tries to teach us is that like enums can store some values, basically of different types. So quit is gonna be like just quit, and move obviously gonna store a point, and echo gonna store string, and then change color could be anything, but we could name it like, no, it stores it's color, so it's gonna be 3 1-byte integers on side, of course. And now we only left with resize. So I think it can have like named fields, it seems. Okay, so we can do it like this. Could be anything. It's width and height. It's obviously not an assigned integer. Oh, let's go with user32. Or maybe like U64, because that's what they use for points. That makes sense. And we need to like actually name it resize. Okay. Implement the message variant types based on their usage below. We have state, it has width, height, position, message, and color. And we have some traits. Create a mesh expression to process different message variants using the methods defined above. Okay. So I think what we should do is to basically create the same kind of struct we just did, but go like these different functions based on what kind of enum value we have. So it's not a struct, I'm sorry. I meant create this enum message. Let's see how they show it in the Rust book. Okay. So it has 5 methods. So we have like resize, then we have move, echo, and change color. And also quick. On resize it has width, which is used 64 in height, which is also used 64. And move is it has a point, and echo obviously has a string. In this it has 3 integers, 1 byte integers. Now we should do some matching. So we do like quit, then it's gonna be okay. So we need to and it tells us that we need to match every possible enum variant. So we have message resize, then we have message move, then we have message echo, and message change color. So for size, we call self for size and give it width and height. For move, do we need to create some kind of variable? So I guess it's gonna be point, right? Okay, so let's move position. Oh, they also provide us with variable names. So for echo, it's gonna be s. And self echo, yes. And for change color, it's gonna be red, green, and blue. I think it should be basically all we have to do. Okay. And now we're going to strings. Fix the compiler error without changing the function signature. I think it wants us to do this. We already seen it, right? Let's check the solution because I'm pretty sure they expect us to do this. No, they didn't. But they say it's inequivalent, so should be right. But we could also try doing it with the toString method. Sorry, trait. Okay. keep the compiler in the main function without changing this function. So I only need to change main. And we're calling is a color word. And what's happening is it says that arguments are incorrect. Okay. And I think we need to like do some reading for this one. So we can store UTF-8 encoded text. This is good. You can have a string literal, and you can convert it to like a string struct with this toString trait method. Okay. I mean, technically it's a trait, right? And you can also do this, which is, as we already know, basically an equivalent. Okay. But now we need to do the opposite. We have a class and we want a string slice. It seems. String slice. So is updating, no need updating. We need slicing strings. Okay. But doesn't really tell us how to do this. Doesn't, right? I wanna like try solve the whole string. Maybe we can just do like this. Okay, this works. Good. Let's just check solutions just to be sure. Okay, so it seems that there is an automatic conversion from like a string struct reference to like this string slice type. Okay. Remove white space from both ends of a string. Compose me. Add a word to the string. So those are functions. Okay, add the word, so not a word, but like literally adds this to the string. There are multiple ways to do this. Okay, I mean, the most obvious one gonna be something like input plus word. And it doesn't allows us to concatenate anything because string concatenation requires an owned string on the left. So I think it wants us to do this. And also there was a chapter maybe like sub-chapter on concatenation. Alright, you can do like this, but you need a string struct. You can also do this, which is what we need right now. I think we did it in a correct way. And there is also like trim. Can we just go like string trim or something? White space from both ends. Okay. Useful methods like contains and replace. Maybe we need to check out the like Rust standard library string methods. Okay, so let's see what kind of methods string has. It should have a trim, right? Yeah, so just a string. It's gonna work because we have known it will work. Strangely enough. I mean, it makes sense, so we don't really modify the initial string, just create a new one. And there we do actually modify it, like, I don't know, it's weird. There also a string concat, right? No. Okay, maybe something like add. No, no add. Okay, I'm drawing the standard for now, but let's proceed. And for replace, we do like this. Right, we do it like this. It is a string. It also needs a pattern. So we're replacing cars with balloons. And it does work. Or does it? Because balloons has two O's, not just one. Okay. Goals of... Oh, I think you also need to check like solutions for strings 3. You can use this. You can also use format. And the other two functions is basically what we did. Okay, so let's start the first fourth strings exercise. Goals of this function should be replaced with goals of string, slice, or string. Here, a bunch of values. Some are strings, some are string slice. Our task is to replace placeholder with either string slice or string, depending on what you think each value is. So this is obviously a string slice. This is a string, obviously. And this is also a string. And I think let's check what to own does. Does it actually explain? Is it actually explained there? No, it didn't. Well, let's check this. Allocates a reference counter and copies v into it. So it returns a slice, right? Or so it seems. Okay, that's not. It returns a string, but it kind of shows us string as a primitive type. Okay. So maybe like they're both kind of equal. Okay. And what does into does? I think for into it, like all should be correct, right? So this gonna work, and this also gonna work. Because I think it kind of tries to match whatever type you give it. Okay, next one is format. I think format gonna return a slice. No, it doesn't. Okay. This is a byte indexing, not character indexing. Okay. I mean, this is obviously a slice. But this, I think it will return a string. No. But why? Okay. So, okay. Well, maybe it does make sense. And this is also a slice then. And this isn't a slice. Why? Why? I mean, it's basically a guessing game at this point, right? I mean, we could just like go there and do like to lowercase. And it says right there that it returns a string. But why it returns a string? And this one returns a slice. Why? Okay, so maybe because when you're trimming, you can remove like indexes from the left and from the right and use the same string But when you're replacing, you're basically obligated to create a new one. Maybe it has to do something with that. Let's check out the solution. Both answers work. Okay, yeah, we figured this out. Okay. Okay. Nothing really new there. We just go to the next one, and it's modules. Modules. All right. Managing growing projects with packages, crates, and modules. We should understand how it's gonna work in terms of like exercises. Let's see. I think the compiler error about calling a private function. Okay. So we can declare modules like this. I think we just do it like this, right? I mean, this is easy. Let's maybe check out what the solution says. It doesn't really say anything. Okay, so I had to take a little bit of break due to some circumstances, and now we can continue. So what we did is we added like pub keyword to make the function of this module public, so we can access it. And actually what I noticed, that it like straight up just tells you that you need to do this. Okay. Let's go to the next one. And the sound should be good, right? Yeah, seems so. You can bring a module paths into the scope and provide new names for them with the use and as keywords. Add the following two use statements after fixing them. So, have a module which is delicious snacks, and it has like fruits and wedges. Okay. So, I think it wants us to do something like this. Use self. No. Maybe like use self. Fruits, beer as fruit. Okay. I'm not sure if this is correct, but seems so to me. I did a mistake somewhere, but where? Fruits, cucumber. No cucumber. Why? Okay, because it's wedges and fruits, right? Oh, did fix it. Let's see the solution. Solutions, modules. Okay. can use the use keyword to bring module paths from modules from anywhere and especially from the standard library into your scope. Bring system time and Unix epoch from the std time module into your scope. Bonus style points if you can do it with one line. I actually don't know how to do it in one line. So from what I've seen in Rust, you can do it like this. Okay, but more like this already. And also need Unix epoch. Let's see the solution, but I'm sure I'm correct. This, yes, really easy. Okay, hash maps. Basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits in the basket and the total count of all the fruits should be at least 5. Okay, so we need to create a hash map and we need to like put like different fruits into it. And like the total sum should be at least 5. So we can like put 2 bananas, I don't know, like 1 apple and like I don't know. So to put the fruits, we can do something like this, as it already like shows us. For example, we can put like 3 apples. And we can put, I don't know, 1 mango, right? The hardest part is gonna be how to create the hash map. And we're gonna read about it right now. Okay, creating a hash map. Well, it seems that you can create it without any types. I think it could like infer the types like from us doing inserts and stuff, right? But is there a way to like explicitly declare hash map? Or should you even explicitly declare a hash map? Okay, hash map. Hash map. Okay, so yes, it can infer the type from inserting. But you can do it like this. So let's try it. Let mutable basket equals hash map new. So I think that would mean that we couldn't do something like, I don't know, like 10, right? Yes, does mean exactly that. But we could also like specify the types directly, so we can do like this. Or can we? Does it actually show you how to create a hash map? I mean, so semicolon. What? Oh, so you need to do it in this way actually. Yes, should be. Oh yes, it can infer a type from like this. Okay. Okay. We're collecting different fruits to bake a delicious fruit cake. For this we have a basket which will represent in the form of a hash map. The key represents the name of each fruit we collect, and the value represents how many of that particular fruit we have collected. You must add fruit to the basket so that there is at least one of each kind and more than 11 in total. So we can insert fruits we already have. So it creates a hash map. It has this amount of fruits. So it has like 4 apples, 2 mangoes, and whatever this is. And it's already 11, right? Insert new fruits if they're not already present in the basket. Note that you're not allowed to put any type of fruit that's already present. Like, how do we even okay, so alright, so it gives us a mutable reference to a hash map. Okay, so we need to be able to check if a key already is present in the hash map or not. So, okay, we can do like this, but so we can like okay. So can we do something like basket entry? We give it a fruit or insert and let's give it like 10. Should work, right? It did work, but let's check solution. Basically did exactly that. Okay. A list of scores of a soccer match is given. You have to build a scores table containing the name of the team, the total number of goals the team scored, and the total number of goals the team conceded. So this is like results, and gives us a string. Then it iterates over each line and it splits it. And so we don't have no errors, so we use an wrap. Okay. You need to populate scores table. Okay. So where's the hash map? So scored and get city. Well, okay. So I think what we do is we need to date in the hash map. You can overwrite a value. You can use like this. So date in a value. This is what we need. And how to exactly updates it. So what we do is we like do team 1 or like current team 1 current score equals results entry team 1 name or insert team 1 0 or insert 0. This will make more sense. And then, okay, now method named entry. Because it's not results, it's scores. Is inferred to be in the problem. Well, this should give us a string, right? So what's the type of it? So maybe we need something like thing like this. Has type. Okay. But no. I mean, we give it an integer. Oh, now I get it. Now I get it. So we insert this. It's a struct. It has a struct. So we need to give it a struct. So it's a struct team score. So the hash map, it has a string and team scores struct. So we need to initialize an empty struct. Why doesn't give me completion for this? Scored. Okay. I need to just copy it. It's gonna be the same for team 2. But then what we do? I also think we should rename it to Team 1 Sports. I can't do reference face. Okay. I honestly don't think it's gonna work. I think I'm kind of getting tired. It should be the last exercise probably for this session. Okay. And this did work for some reason, but I don't actually know. So let's maybe check out the reference to std library. So what's in the entry? So it returns us this. Okay, but then we do this. It returns a reference. Okay, so this is a reference. And because it is a reference, we can just set it. Makes sense. But then let's check out the solution. And they basically did the same, but they also used this default thing that makes it that you don't really need to do this. Okay. But now why do I get some errors? No field? What do you mean no field? What's the difference? So it's using insert with. And what's insert with? Ensures a value is in the entry by inserting the result of the default function. So basically this is a function, it seems, and we're returning a function instead of a struct. Okay, oh, it's a quiz, so let's finish the quiz and that's gonna be all for today. On this quiz number 2, quiz for the following sections: strings, vectors, move semantics, modules, and enums. Let's build a little machine in the form of a function as an input, we're going to give it a list of strings and commands. These commands determine what action is going to be applied to the string. Can either be uppercase the string, trim it, append bar to the string a specified amount of times. The exact form of this will be the input is going to be a vector of 2 length tuples. First element is the string, the second one is the command. The output element is going to be a vector of strings. Okay, so this is the input. So we have this enum. And this transformer function. What do we need to import? Transform in the scope. Okay. So we need to write this function. And receives a vector. But should it really, so it transforms, so it creates a new one. Okay, so we can basically move it and it will be okay. So we have input, and the input is of type. How do we type tuples exactly? It was a string and also a command. And okay. Oh, this actually looks fine for some reason. So this is a unit type. But we have a tuple there. So we like to just like this. Oh, we don't. Okay. This is pretty interesting. Does they give us any tips? Okay, they do. I mean, I could just Google it, but it doesn't seem like the... I don't mean Google the solution, but Google's the... how to type tuples. I mean, this is how you type a tuple, right? But for some reason... expected this. Oh, I did type it correctly, but just didn't return anything. Okay. But we also return a vector of strings, not so like this. This should be a bit better. This should be a bit better. And we need to create like a mutable output, which is gonna be okay. This does look good, but then we can just do something like input, I guess. Something about an iterator. I think there in the std we can make vector into an iterator. I think it's two iterator. It's two iter or something like this. No? Okay. We do this, and then we do this. And what we get? Well, we get this. We get string, and we get cmd, right? And we'll redo this. Well, do like something like collect and whatnot. Okay, closure is expected to take one argument, but it takes two arguments. Well, okay, so it wants string from us. And then what we do is we do match. And so how do we match tuples? Struct literals are not allowed here. Why not though? I'm doing like a match. Okay. This does look better. So it's two uppercase. Okay. We also have three, so it's something like this. Basically three, and we just do just that, do three. And then we have paint, and I guess count, right? And we do something this count. Compatible types. Why? Okay. I don't find transformer. What do we need to import this? Okay. Well, I guess we need to do this. Okay, we removed one of the errors. We still have some errors. This is found to be of type string. And is this? I mean, this should return a string already by default. Okay. And I'll see what happened. But we also need to check what we can do with strings. We should have like insert. Or maybe like duplicate or something along those lines. Have insert. I mean, insert is good, but it's not what we need. Well, we could do it. How would we do this? So we need to like add bar a bunch of times. Exactly, we need to add bar 5 times. Okay. What methods do we have? I mean, I could write a for loop, right? But is writing a for loop is what we actually want. I mean, let's do it the dumb way, okay? So for I in, I guess, what we're gonna do is we do this. We do push. Maybe not like this, maybe something like let s, and you should make it mutable. And you should make it a string. Mismatched types. And this is better already. But it wants an integer. I'm not good with ranges in Rust. I think we're doing something wrong there. To what exactly? Okay, we can repeat it. Okay. So shouldn't do this. What we should do instead is we should do this. S, no, not S, bar, repeat, count times. And Okay. This looks kind of dumb, but it did work. So let's see now a solution. That's basically what we did, to be honest. But actually, can I use a cool like mapping thingy? I think I'm smarter, you know. Okay, so this was kind of challenging, to be honest. But well, it's good. It means that I have kind of learned something, I hope. And we will continue next time. So thank you for watching. See you next time.